So continuings from the previous videos, we'll talk about the spin-off build in the more detail. So in the previous videos, we discussed the three different build, the scalar spin and surround vector build for the spin zeros, 1/2, and spin ones respectively. And today we'll focus on the spin-off build for the which are described by the Dirac equations for the brief build case. So in the Dirac equation case, the Lagrangians are written by this form with the gamma matrix to make the Lorentz invariant Lagrangians. The detailed derivations of the Lorentz invariance of the such a quantity psi bar psi with adjoint spinor or the psi bar gamma map psi, which is behaves like the vector field. So the such a detailed derivations will be discussed in the later. But this will focus on the what is the gamma matrix. The gamma matrix is a 4x4 gamma 4x4 matrix, and there are four gamma matrices with mu equal to the 0 to the 1, 2, 3 as a space-time index. So the contraction between the gamma mu and the space-time derivatives partial mu is actually the summations of this form. And actually this gamma matrix becomes the commutates of the gamma matrix, gamma mu and gamma mu. Which commutates are proportional to the capital sigma mu, and such a capital sigma mu becomes a generator for the spin or boost transformations of the Frankel algebra. So the is related with the Lorentz invariance. So there are generators exponentists. So there are generators capital sigma mu and the parameters. So the boost parameter of the rotational angles that are being used. So this becomes the transformation, and it acts on the sum of the build, for example, spinor build. Such a spinor build besides are transformed by this some transformations, and some properties of the gamma matrix make that this quantity becomes a Lorentz invariance, and that exact derivations will be discussed in the other video. So today we'll focus on the gamma matrix. The gamma matrix is a 4x4 matrix, which is the consists of the Pauli matrix. So in the off-diagonal terms, there are Pauli matrix sigma I and minus sigma I. For the I equal to the 1 to 3 as a partial index. For the temporal index, gamma zeros, for the Dirac representations, the gamma zeros are given by the identity matrix in the diagonal term. And there are one more additional term, gamma 5, which gives the chirality. In the Dirac representations, the off-diagonal terms are given by the identity matrix. But there are certain representation, bar representations, which is represented in the this left-hand and right-hand spinor basis. This is useful for when we consider the chirality basis. In this case, the gamma zeros and gamma 5 matrices are swapped. So there are some of the transformation relation between the Dirac representation and the bar representation for the gamma matrix and spinors too. In the bar representations, the gamma matrix can be written sort of more abstractly. So that in the mu equal to the 0, 1, 2, 3 index, the gamma mu's are given like that. So with the sigma mu's are defined sigma mu and the sigma bar mu's are defined at this form. It is possible because the gamma zeros has identity matrix in the diagonal. And we'll use the bar representations frequently. But sometimes we use the representation, for example, the finding the solution for the Dirac equation. So there is a gamma matrix, and the gamma matrix acts on the Dirac spinor. The Dirac spinors can be written by the several forms, like the Dirac spinors or bar spinor. And for the Dirac spinor case, the psi is written by the psi d, and the upper two components that correspond to the particle solution, but the lower two components that correspond to the antiparticle solutions. So we will find the exact solution to the Dirac equations in the next video. About the bar spinors, the upper two components correspond to the left-hand is color state, and the lower two components correspond to the right-hand is color state. The transformation between the drug spinor psi D and the bar spinor psi W is given by this matrix. There are some several quantity for the gamma matrix, which is frequently used, for example, the calculation for the QED. The anti-commutators of the gamma matrix is given like that. So this anti-commutativity properties related with the Grossman numbers of the spinors of the gamma matrix. So anti-commutators of gamma mu and gamma nu equals the matrix times the two in the blood space time, and gamma pi or gamma mu is anti-commutes. Also, there are some of the advanced topics, which is three equations in the curved space-time. In this case, they use some of the Biot field to describe the coupling between the gravitons and the spinor field. But I will not discuss. So I see. And then there are also the quantity for the scales of the gamma matrix. The scales of gamma 0 and gamma 5 gives the identity matrix. And the scales of the gamma matrix for the partial index gives a minus identity matrix. And the gamma 0s and gamma 5s are Hermitian, and the gamma matrix with the partial index is anti-Hermitians. If there are some of the some general spinors quadratic form of the spinors are given, then that is represented by the bilinear covariance as a basis. So the spinor has four components. So that there are four components of the psi bar at the joint spinors and the four components of the spinor. So the degree of freedom is 16. And so that there are 16 bilinear covariance bases. So first of all, there are scalar, which is transformed by the Lorentz invariant scalars in the Lorentz algebra transformation. And there are also pseudo scalar, which is the gamma pi matrix inserted. But the pseudo scalars, has all the parity for the partial inversion. So there are degree freedom for the scalar for the one and the pseudo scalar for the one. And for the backtest, we already see that the psi bar gamma mu psi is the Lorentz backtest. There are degree freedom 4. And if we insert gamma pi, there are it becomes the axial factor. For the parity transformation, vectors has a minus sign, but axial factors has a no sign for those partial component. And finally, there are the tensors, which is insertions of the commutations relation of the gamma mu and the gamma nu. And there are combinations for the 3, so there are 6 degree freedom. So the total degree freedom becomes 6. Also, we can, in this sort of the biological covariance, the numbers of the gamma matrix. For the scalar case, there are no gamma matrix. For the fact there are 1 gamma matrix. And there are for the tens, there are 2 gamma matrix. And the gamma pi is defined as proportional to the I gamma 1, gamma 2, gamma 3, gamma 0. So there are 4 gamma matrix in the gamma pi matrix. So for this axial factor, there are 3 gamma matrix, and by using the scale, scales are proportional to the identity matrix such as identity. And for the gamma, for the pseudo scalar, there are 4 gamma matrix in the inside. Finally, so today we discuss spin sum derivation by using the projections of this spin sum relations is actually the outer product and usually applied in the QED calculation. So the U and the U bar is some spinor solution. So this is the outer product of the spinor, and if these spin sums are X on the sum of the other spinor U, so that this outer product is actually the projection operator. And by using the orthogonality between the spinors U and the U bar, so this is the inner product here. And by using the normalization, so this U by U becomes a 2 arm. I just ignore some of the detail index here. So this gives the 2 arm nu. If this projection applies to axon and particle, by the orthogonality, this yield zero. So by using the equation of the motions, zero equation, this is zero equation. So this 2mu can be expressed by the p cancel, which is a p cancel the gamma mu p mu production between the gamma matrix and the four vectors. This is the momentum vectors case. So the result of the spin sum u bar is the p cancel plus r. This spin sum formula will be used in the like this. So this is some of the detailed discussions on the gamma matrix and spinors, and in the next video, so we will talk about the solution of the two equation for the separate cases.